Yes, thank you. Thank you very much. So here we go. Today we are going to discuss about the second part of the PGP. So in this we will discuss further about the PGP, and we will also see that how this is actually working and the other details as well. PGP, now I believe that you already know a great detail about the PGP after what we discussed in the tutorial and in our last lecture. But again, the few of the most important points are still there to know about them and to know how the PGP protocol is actually working are still there to cover. That part we are supposed to discuss today. As we know that the PGP is actually about the email security. And we are also aware that email is the one of the most important and one of the most used source as well for communication and exchange of data. On the other side, we also know that the email is the one of the major source for the hackers as well for sending the malicious emails to the single users and to the organization users as well. Now, why we are focusing, or why the people they started focusing for the PGP, why they feel the need that PGP is required, though we now know that PGP is the something which is actually providing us the security as well as it is providing us the solution for non-repudiation by providing the DSA as well. But why it was critical? Though we know the email is the main source, though we know that email is the main source for the hackers as well, for the malicious emails as well, but the actual thing is still something is behind. That was the reason we tried to come up with a solution. What is that? Everybody knows that we are using the email protocol, which is the SMTP. SMTP is actually stand for Simple Mail Transfer Protocol. There was some issues, other problems with the SMTP. So we thought that we may have a proper solution to address that particular part, and that's why we realized that PGP is required and PGP is important as well for us. So what is that issue, or what is that problem is that we are going to discuss in a couple of minutes. As we discussed already, that for the email security enhancement, our primary goal, our primary target is about CIA, and the last is we need the confidentiality, authentication, integrity of the message, and non-repudiation of the origin as well. We're not going in a detail because this we already discussed several times in our previous lecture as well as in our tutorial. This was actually a target to achieve from the email. Now here is the point that what we were discussing. So you can see from here, this is the breakup of SMTP protocol. SMTP protocol is actually stands for Simple Mail Transfer, and we are very much well aware that the SMTP is the protocol for the mail. So these are the lines. I'm just going to read it from top to bottom, and you can get the right message, and then I will explain you what was the problem. So you can see the first line, it starts with the S220 smtp.example.com ESMTP postfix, and then it's saying that hello, and then the relay example.org, then hello relay example, I'm glad to meet you, then mail from with person ABC email address, and then 250 OK, and who is the recipient, address is given. So it seems that recipients are more than one. Okay, data started. Okay, hello Alice, your friend Bob. Okay, and whatever the further message, and it's queued, and now it's ready to go where we are saying bye. Now this is the format of the SMTP protocol, how it takes the data from the one sender to the other sender. Now what is the issue in it? That's what we were discussing. If we see from top to bottom, maybe we may not find any critical issue. But when we see it from the security perspective, we can find a really very severe issue in it. What is the severe issue in this? The severe issue in this is actually that you notice that this all of the code segment is taken by the SMTP going in a plain text. The data is not encrypted. So what about the main and the middle tag, or anyone else who can come in between? So the text is simple. Someone can breach it, compromise it, then that person can have the contents of your email, can read it easily. But this was the major concern. So that's why we come up with the PGP, pretty good protocol. Going to the next slide. So what was the issue? We already discussed that this is the SMTP is carrying data, which is the plain text, and everyone on the way can read it. Anyone who wants to interrupt your data, then they will have a chance to read it easily because there is no encryption. But the thing is, whole thing is in the plain text, so it is easily doable and readable. Now, no authentication as well. Everyone can post as everyone. What it means? It means that it is even easier for the hackers. They can post I'm the right user, and it becomes easy for them to grab the data. On top of that, it is in the plain text. So once if suppose they grab it, so then it becomes easy for them. Now, another issue with the SMTP protocol was about its size. That was critical as well. So we have to have the size limit. That's why this is the another issue of the SMTP. So now what's the solution? Where is the solution? So now the solution is actually PGP. So now I hope that you understand the crucial reason that why we need the PGP. Other than the all other reasons that what we discussed already in our previous classes as well as in our tutorials as well. Now, what are the features if suppose we go for the PGP? It has very nice features and it overcomes all of the issues what we were facing with the SMTP. Number one, authentication mechanism is there. Number two, confidentiality is there. Number three, message compression is as well as there. It can compress the message. You remember in SMTP, we said that message size matters. So here we are compressing the messages and also we are doing desegmentation. So we can accommodate the large message compared to the SMTP. We can provide the confidentiality. We can provide the authentication. We can do the message segmentation. These all are the features. They were not there with the SMTP. So, going ahead, how it is working, if you remember, in the last class, also we discussed the initial thing, that how this is working. So you remember, this is the message. This is, we are trying to compress, so which is the zipping. This is the encryption. This is the key. This is the public PU is the public key, and this is the encryption of the public key. And here we are trying to concatenate them to join this all, means to fetch it with the message. So you can see from here, and this is at the top of the message. So now here is the private key for a P, and here is the decryption, and here is again you can see decryption and Z-1. So now here we zip the message, and now here we are trying to unzip the message, and finally we are receiving the same message. So if you just go through from the points, senders forms the 128-bit random session key. As you remember, we discussed in our previous class as well, that here we also manage the sessions as well. Encrypt the message with the session key. Where is the session key? Here is the session key, which is known as the KS. So we need to encrypt the message with the session key. So we zip it, this is the message, we zip it, we encrypt it, and then we encrypt it with the session key. Now, receiver decrypts and recover the session key. So he will decrypt it and he will recover the session key. Session key is used to decrypt the message. So here after encryption, we are applying the session key so we can enhance its further security. Now the point is, what is PRB, what is DP, what is DC, what is EP, what is KS? Very simple. Just go to the next page. These all notations are, try to write it separately. So you can see from here, this KS is the session key. So you can see this is the KS, this is the session key. So you can see from here, encrypt the message with the session key. Then when we come back, so this is PR, this is the private key. But why the A? A means on the left side, which is the center, and the B is on the other side. RB is here and A is here. So means this is actually representing to the one on the side. Now PRA, so you can see here we are saying PRP because here we are coding one. So in this, you can find out that B is representing to the side, like suppose center of the receiver, and P is private, PR is private, and PU is public. So you can see from here, this is public, this is private, and EP is the public key for encryption. So P is for public and A is for encryption. DP is the public key for decryption. So go back, so you can see from here, this is the DP and this is the EP. So what's the EC? Symmetric encryption. So you already know what's the symmetric encryption and asymmetric encryption. And the DC is the symmetric decryption. So this is encryption, this is decryption, this is the decryption key, this is the encryption key, this is the public key, this is the private key, this is the session key. Go back and see from here. So now this will be very simple. You can understand it very easily. Further, H is for hash function. And this sign, what we call the function, is actually for concatenation, means that when we are joining. And C is actually for compression, using the zip algorithm. So we are using the zip algorithm. We are trying to compress the data. See here now, for your further means understanding. Now from here you can see this is the A and this is the B. So PRA means this is for this part A, and this will be the B, whatever is mentioned here, there will be on the something which is related to the B part. But now what he is showing the one of the complete component to you. Anyhow, you see here, this is the message, this is the hash function, this is the encryption key, this is the private key of A, this is what we are doing concatenation, and then finally we are trying to zip it. So when we zip it, so the message is now in this format. So this format message is actually that you can see to compare with this format. Now it's totally changed because we apply the hash, we apply the keys and everything. Then when it's reaching back, so what we are doing, we are unzipping it, and then finally we are applying the hash and applying the decrypt public key, and then we are trying to compare with the previous one. If it is same, then we can say, okay, why we are comparing? Because we are comparing to see that the data integrity is there. Now, what's the next? The next is one more notation. So here we can see for the confidentiality indication how we are doing. So again the same. This is message. We are applying hash. This is the private key A, and this is the encryption key. Then we are trying to concatenate them. After that, we are applying the zip, and after zipping that one, this is the same pattern that what we did in our part A, where we are applying the session key, and again we are applying the encryption key and private key, and then the messages actually reaches here, and on the other side, this will be happen totally in the reverse order. So this is how PGP is actually working. So it is providing us capability of zipping, unzipping, confidentiality, authentication, as well as for the segmentation. So these are the things which are means not available in your SMTP. So now you will be knowing what are the core reasons and how this is critically different from the SMTP. Now we go to the next slide, so we can find here about PGP operations. So the compression is the major operation because it enables us to carry the higher size of the message. By default, the PGP compress messages after signing, but before encryption. So when we put the signature, after that, we apply the zipping. This is the normal format. And then we can encrypt it again. So compression is actually, we're doing it before as we can decompress it and any of our key may not create the issue for us. And we are using the zip compression algorithm where we compress it completely so we can see how this thing can happen. Now how the sender is sending the message and when the recipient is receiving. So this is how we are doing with the help of the PGP, which help us to save our bandwidth as well. How? From the sender, it is signing, applying the compression, and then encryption, as we just discussed in our previous slide. And after that, it is sending a message. And when the message is going to the recipient side, so then what happened? The decryption. For the decryption, now because the message is already compressed, so we have to decompose the message and then we apply the authentication. That in case if suppose we are authorized, only then we will be able to receive the message. Now, what are the PGP operations in the email? These all are the things beside that. When using the PGP, we'll have a binary data to send. So we can do the encryption, compression, and all other operations easily. So because we know that the email is basically designed for the text. So PGP encode the raw binary data into actually the printable ASCII characteristics. And then it do all of the operations. And it uses the radix 64 conversion, which is for the conversion method, where in which each group of the 3 octets of the binary data is mapped into the 4 ASCII characteristics. No need to go in depth or in detail for that one, but this is just only, the 4th point is just only for your information. Going ahead, session key is the something important concept in the PGP. This also enhance or increase the level of security for the PGP. So need a session key for each message. So whenever we send a message, we always need the session key or the session, which varies from 56 bits DES. So you know that what is the DES, and 128 bit for the class or IDEA. So maybe 162 bit triple DES. So these all are the actually algorithms. So when it goes with the session key, so it requires to encrypt using either DES, either COST, either IDEA, either DES, which is the triple DES, because DES we already said, but it is not using AES. So what it means, that bottom line message is that the session has to be applied the key. So you remember what we discussed, that KS is representing to the session key. Now generated using the NCX 12.17 mode, or we can use to generate any other. This is not an issue. So it's just only for your brainstorming. Users random inputs taken from the previous users and keystroke. So what you mean that this operation is going to be done randomly it is not fixed even, and not the key is also not fixed. Our algorithm is also not fixed that always it will take this one. It depends. It's randomly going to be changed time to time. Could be the same and could be changed in when these cases are happening in a way. Now, what is the PGP public and the private key? So this concept is number one, since you know about the public and private keys that may be in use, why they are may be in use, because we need them to identify that the which actually encryption we used, method we used, how we encrypt the message, and what type of the key actually we apply. And then because that all information is actually required to us, while we'll be going to decrypt the message at the same time. So this is how means number one, number two, and number three for encryption and decryption, and also for the digital signature. So this is how the PGP is working. So if we conclude it, we can, then it is using the session keys. It is providing us the authentication. It is providing us the confidentiality. It is providing us the compression. It is providing us the segmentation as well. PGP key management is very important, which actually enhances the security. So rather to rely on the certificates like what the other protocols are doing, here we normally use the keys for the session, so that keys can help us and to control, to enhance the further level of security. Now, as you already know more details about PGP from your last class, as well as from your tutorials as well, and I hope that maybe you go through one of the demo software as well, how it is going to be applied. If not, we are just going to share with you one other simple example. So here you can see from this example, the link is given. So this is the PGP key generator, and the website name is iGolder, and the link is given there. So this is only, you're not supposed to install anything. This is only just you send an email to yourself and just means provide all of the information and just write your contents, and then you just say that you are just going to apply the PGP. So it will show you that how the PGP is going to be applied. So practically you can see that what we are discussing and how these things are going to be implemented. So it will show you and at the same time, so just for your concept clearance and how the PGP is working. So if you wish, you just go to the iGolder.com, so you will be able to know that how these things are working. So we covered about the email security, PGP introduction and its process, PGP operations, and PGP key management. Yes, PGP is important. That's why we discussed it in more than one sessions, and also we try to cover the things which are not covered during our tutorial as well. So this is all about PGP. So what we can see, you can see this code that I can't change the direction of the wind, but I can adjust my sail to always reach my destination. This is the best suitable relation, most likely and most in line with our situation. So what we can say or what we mean that if we cannot fight with the cyber threats, cyber security threats, okay, but at least we have to means adjust ourselves in a way that we may reach to the destination without any loss. So that's what we are trying to focus. That's what we mean that if suppose we are using the PGP, so it means you are trying to avoid the issues and the problems. But again, there is no surety, there is no security 100% as what we discuss all the time. Thank you very much for your time, and I hope that you understand and you enjoy the lecture as well. Now PGP concept may become a piece of cake for you. So thanks again. And now if supposed to have a question, please let me know. If you don't have any question, then we will go for the attendance. So if you don't have a question, I may request you to please stop the recording as we can go for the attendance.